Hello guys, my name is Yurii Babich. I'm PhD in telecommunications and I work at Odessa National Academy of Telecommunications. And today we're going to be talking about current trends in infocommunication networks. We're going to take a brief look at job requirements to networking specialists. And we're going to briefly cover education opportunities brought to you by the Bologna process. So let's begin, and precisely we're going to take a look at convergence and virtualization. But before getting to these trends, let's define the driver that moves the network's evolution. Basically, any telecommunication company, internet provider, or any business in this area actually can generate profit in two ways. The first option is to transport subscriber traffic and to charge for that. The second option is to provide additional services. So the network evolution actually allows to either utilize network resources more effective or to provide more additional services. So let's start from the convergence. Convergence refers to two or more things coming together, joining together, or evolving into one. So pretty simple and straight definition, but let's find out how it affects networks, how we can spot that process in real networks. Actually, convergence in networks can be split into three separate processes. These are convergence of networks, convergence of devices, and convergence of services. So let's start from convergence of networks. Basically, convergence of networks happens when different networks with a different technological basis unite into a single network. Let's take an example of Kyivstar. So they have started as mobile operator, but now they have pretty significant wireline segment due to their internet service providing activities. And that is the effect of convergence. Convergence allows network operator to support more subscribers and to provide more services, thus to generate more profit. Now, let's take a look at the convergence of devices. Convergence of devices means that separate devices tend to unite into a single device in order to provide new services or to get some new features for existing services. For example, let's take iPad. iPad is a combination of TV, computer, and a smartphone. So, with the iPad, we can provide more services to a subscriber. So it is convenient for subscriber and it generates more profit for network operator. Another example I can think of is the smart TV. It's a combination of monitor and computer. But network convergence affects not only terminal equipment. Terminal equipment is the appliance you use. So it's your phone, TV, etc. But it also affects networking devices. Let's take a multi-layer switch as an example. So multi-layer switch, it's a combination of a switch and a router in one appliance, in one device. Basically, a router connects different networks, while a switch enables communication within one local area network. But a multi-layer switch is capable of acting as a router and as a switch. So it's a combination of both. And that is the result of convergence of devices. The next process is convergence of services. The idea behind the convergence of services is that the same set of services should be available to you despite the technology you use for access. It doesn't matter if you use PC with a usual wireline connection or you use a mobile phone, you should be able to get approximately the same set of services, and that is the result of services convergence. Now, let's move on. Let's talk about the features of modern converged networks. Precisely, I have pointed out two features. The first one is the fact that such networks are user-centric. User-centric means that you, as a user, decide which services you want to get, when you want them, and how they must be provided. And accordingly, a network has the platform to interact with you. So this makes the converged networks, modern converged networks, user-centric. Another feature of converged network is that they use packet transport. So they are based on packet technologies. And let's find out why the packet technologies are the basis for almost all modern networks. And packet technologies are so popular because of their efficiency. Let's consider a simple example. Let's assume you call your friend with a traditional telephony. In this case, there is a channel established between your phone and the phone of your friend. And no one else can use this channel, even if you don't talk. So information is not transmitted, but the channel is occupied. Is it an efficient way to use network resources? Obviously, it's not. What happens in the case of voice over IP telephony? In this case, when you talk, your voice is carried in packets. A packet is a small portion of data attached with a header. The header is necessary to route the packet correctly. So, if you don't talk during the conversation, there are no packets sent, and thus someone else can send the packets. So, that's why the packet technologies utilize throughput of networks in an effective manner. Now, let's take a look at the basis of all packet networks. It's a TCP/IP protocol stack. So, let's start from terminology. Protocol is a set of rules for interaction. Stack means structure of protocols. So, this model of TCP/IP stack is defined in RFC 1122. RFC actually is a request for comment. It's an international document issued by Internet Engineering Task Force. This document is available to all the vendors of all the equipment, all the software developers. So everyone involved in industry knows how a packet network works. So which protocols operate at which layer. So I think here you can find some protocols familiar to you from the school course, like Internet Protocol IPv4 and IPv6, Ethernet, which is the golden standard for local area networks. So here is the basis for packet networks. So the first trend of modern networks is the convergence. Another significant trend is virtualization. Virtualization is essentially the process of creating a software-based or virtual representation of something, such as servers, computers, routers, switches, etc. Basically, what happens when we virtualize something? We create a software representation of some hardware. And such a representation, this virtualized entity, is usually called a virtual machine. Now, let's talk about why virtualization is the popular trend in modern networks. In this figure, we can see three traditional hardware servers. The first one is email server, the second one is CRM server, and the last one is the file server. The problem with the traditional servers is that they work with a designed load approximately from 15 to 20% of time, according to existing statistics. But you pay 100% of their price. So, to increase the extent of equipment utilization, we can virtualize these servers and run them on the virtualized server. So the idea is to implement these servers in a software and run on a single virtualized server. So, since we reduce the amount of equipment, then it will be easier to maintain our infrastructure. We're going to need less staff to operate this. We're going to need less room to install the equipment. And of course, we're going to save money on electricity and air condition expenses. Now take more closer look at our virtualized server. So, these are the virtual machines. Every virtual machine has its own operating system and applications running on top of that operating system. But in order to create virtual machines, in order to manage virtual machines, we need a software product called a hypervisor. The primary task of a hypervisor is to share resources like CPU, RAM, network card, or disk space between existing virtual machines. A few words about the hypervisors. There are two types of hypervisors. This is so-called type 1 hypervisor. It is also called a bare metal hypervisor. The reason to call it a bare metal hypervisor is because it is installed on top of our hardware. Type 2 hypervisor is usually, here is type 2 hypervisor, so it is installed as an application to operating system. So, about application of these two solutions. Type 1 hypervisor you're likely to see in banks, in data centers, in other words, in industry. So, because it operates much more efficiently compared to the second one. Type 2 hypervisor you can spot in educational environment. It is, these solutions are used for testing purposes and stuff like that. Typical example is Oracle VirtualBox, which is widely used for educational purposes. Virtualization doesn't affect only terminal equipment like servers, computers, etc. So it affects network topology, network architecture, network structure. So let's consider this small example. So here we're talking about VLAN technology. So the technology of virtual LAN. A virtual LAN is a technology that allows us to create virtual networks. So here we see a topology without VLANs. As you can see, here we have 3 routers, 4 switches. But here, with the VLANs, we can dramatically reduce our topology. So here we have only one multi-layer switch. So as you can see, virtualization, and VLAN is the implementation of virtualization. So it allows us to dramatically reduce our topology and to design and build network in more efficient way. So These two, virtualization and convergence, are the main trends for infocommunication networks. Infocommunication is a term referring to all kinds of networks, information network, telecommunication networks, so it's all about this. Now, let's talk about job requirements you're going to face as the network specialist. So, first of all, you got to be a highly qualified professional. And to become a highly qualified professional, you can either go to university, or in our case, academy, or you can go and study some courses available from equipment vendors such as Cisco Systems, Juniper, and Huawei. So, of course, these two options doesn't exclude each other. So, the next option, you got to have strong language skills. Guys, there is no way to build successful career in networking without at least English. I work as a vice director on international projects in Odessa National Academy of Telecommunications, and I typically meet engineers and network specialists having two languages, so it's not exception. So learn foreign languages. That will boost your career. The last option here I want to mention are the soft skills. Even if you don't want to communicate with other people, you will have to as the networking specialist. So there is no way to avoid that. So you got to be able to present your ideas, to communicate with team members in your IT team. So you're gonna need soft skills. And the last point of our today's lecture, education opportunities within Bologna process. So as a student, at least you have to know the possibilities that are available to you. So, the Bologna process is actually a political process involving 48 European countries, and the purpose of this process is to create European higher education area. What is the idea behind that area? The idea of this area is that students can freely travel between universities and study. So what's in that for you? So how it can help you? Basically, this Bologna process, the main mechanism of this student mobility, is called European Credit Transfer and Accumulation System, or ECTS. ECTS means that if you study at some university and you successfully complete a course, you obtain some credits, and those credits are recognized at other universities. So, this gives you opportunity to study in different universities and get diplomas of European universities. Well, actually, in our Academy of Telecommunications, we have more than 10 years of experience in such programs. Basically, you can participate two programs, joint degree program or double degree program. Joint degree means that you study at several universities, but you get only one diploma. Double degree means that you study at several universities and you get diploma from each university you study. What you should consider while participating in such programs, if you want to get a diploma from European university, at least half of your credits must be obtained in European Union. So don't forget this detail, and this, let's say, main feature that we consider in our international cooperations. So guys, I think that's it for today. If you have any questions, write them in the comments below the video. I'll do my best to answer your questions. Thanks. Goodbye.